Okay, so today we're going to do inverse trig functions, and we're going to kind of combine two lessons that we already talked about, the graphs of the trig functions and our thoughts of inverses. So hopefully you remember that from first semester. So let's look at a cosine curve, and you know you should be an expert at drawing a cosine curve. And it kind of hard to do it on the screen really pretty, but you get that looking thing, right? Good enough. And so we know that and even it goes beyond, so it keeps going there and here because we know the domain is all reals, and the range is, of course, -1 to 1. So this is actually, we're gonna get to the graph of arc cosine by first doing it from cosine. So let's look. Remember we talked about first semester is if a function is not 1 to 1, it doesn't have an inverse. So clearly f of x is not 1 to 1, meaning it does not pass the vertical and the horizontal line test. It certainly fails the horizontal line test. So remember how we had to restrict the domain so that it would have an inverse. Okay, here's the deal. Well, you don't get to pick. You're kind of like, oh, there's so many different answers, and I could pick lots of different ones. Well, mathematics, people of old said, you know what? The one I want you to pick is I want you to restrict the domain from there to there. If I restrict the domain from 0 to pi, do you agree that that would be a 1-to-1 function? And then if I went anything beyond that, it would no longer be 1 to 1. So that is the restriction that mathematicians decided to use. So here's the deal. Let's graph the inverse. Well, what do we know about the inverse? We know that the domain and the range flip. So what was the domain becomes the range, and what was the range becomes the domain. So notice on the graph, my x's are the ones, and my on the y-axis are the radian measurement. Now remember, the inverse is called two things. It's called it's denoted two ways, like that, or it would say arc cosine of x. So those two things mean the same. So what would the graph look like? Remember, inverses, we flip points. So this point that was at 0, 1 becomes 1, 0. This point that was pi over 2, 0 is 0 pi over 2. And of course, pi -1 becomes -1 pi. And if I did more points or the paper trick, I would get a shape that looks something like that. So there's your arc cosine graph. This range, just so you know, it's also called the principal interval. I can spell. Principal, oh my goodness, pen. Principal interval. Because it's going to tell you, when we get to the problems, it's going to tell you where to look. For arc cosine, just write this down for now. You might go, I don't understand what you're saying by that. Write it down now, it'll make sense. If the principal interval is 0 to pi, you're going to only be looking in those two quadrants, from 0 to pi. Now here's the deal. I could do the exact same thing for sine and tangent, by drawing the original, restricting the domain, etc. I'm not going to go through that because I think you get the idea. Because again, you don't have the choice. Mathematics has already made the choice for you. So if you look on the next page, I just graphed arc sine, and remember, that could be this as well, and arc tangent, which could be written like this. So notice that the arc sine, the domain is still -1 to 1. So I'm doing the domain and range of this specific graph. But notice that the range, or the principal interval, is -pi over 2 to pi over 2. And with this arc tangent graph, really what's going on there are arrows here, and you have an asymptote here. So with this one, the domain is all reals. The range looks close, but notice I don't have a dot on the pi over 2's, so those are open parentheses. So for both of these functions, if I drew my little circle here and I shaded, I would shade here. Now this is what's weird. I want you to put a star by quadrant 4 because it's the weird one. This is negative pi over 2 and this is pi over 2. Correct? Yeah, quadrant 4 is going to be a weird case. So let's talk about, okay, I get these graphs, but I don't know why they help me. Well, we're going to be evaluating these things. Y'all, it's like your unit circle backwards. So in the unit circle, I said, hey, what's the sign of like pi over 3? And you were like, oh, square root of 3 over 2. You kind of were going that way. So notice I could write the inverse sign of square root 3 over 2 is equal to pi over 3. So the x's and the y's flip. So I'm basically asking you, when you see this, it's saying what arc, and this is going to all be in radians, okay? Of course, we're going to do this all in radians. What angle or what arc has a sine value of 1/2? Now here's where that shading comes into play. Because if you look at the whole circle and I say, give me, what angles have a sine of 1/2, you could technically give me two different ones. You could say pi over 6 and 5 pi over 6. What you have to know with these arc functions, there is one answer. They're functions. Okay, they're one-to-one. So one answers. There's only one answer. So that's why the shading. You can only look in this quadrants here. So if I said, give me the arc that has a sine of 1/2, you would say pi over 6. So is this true? Is the sine of pi over 6 equal to 1/2? Yes. So you must have the correct answer. So let's do B. Arc cosine. The second I see a arc cosine, I end up drawing just what I shaded. I end up just drawing that, so I only look there. Now this 1 over square root of 2, what does that really mean? That means square root of 2 over 2. So who has a cosine of square root 2 over 2? What special angle? And of course you'd say pi over 4, right in the middle. Who, let's look at number C, letter C. Who has a tangent of 1? Well, it's positive 1, so it's going to be in quadrant 1 of your special angles. Who has a tangent of 1? And hopefully you say, well, that's pi over 4 as well. Now let's talk about the negatives, because if this value is positive, you're going to be in quadrant 1. Most people don't miss those. Let's talk about the negative one, though. Arc sine of negative square root 3 over 2. So I'm just going to start by drawing the half circles. Those are the quadrants I'm looking in. Now, if the sign is negative, I think we can agree that it's going to be short in the x, long in the y. So it's going to be right here. But here's the trick, and this is why you put this, and you're going to write name negatively. Because you're not going to call that on these arc sine problems, you're not going to put 5 pi over 3. Is 5 pi over 3, is the sign of 5 pi over 3 negative square root 3 over 2? Yes. But arc sine is only defined, look at this is where the graphs come into play. Okay, arc sine, notice the values I have are only between negative pi over 2 and pi over 2. So that means I have to name an answer between negative pi over 2 and pi over 2. So instead of calling it 5 pi over 3, I'm going to call it negative pi over 3. Okay? And that's true for arc sine and arc tangent. So I'm going to skip arc cosine and I'm going to go to the arc tangent one. Again, that's in quadrant. It's 1 and 4. It's negative, so you know you're going to be down here. Which one of these has a tangent of negative square root 3? And if you have to write the ordered pairs to figure that out, if you remember, it's between these two. So square root of 3 over 2 negative 1/2, or 1/2 negative square root 3 over 2. And divide y over x. So you determine that it's this one. Once again, I do not name him as 5 pi over 3. I name him as negative pi over 3. So basically what it comes down to in quadrant 4, your answers are either going to be negative pi over 6, negative pi over 4, negative pi over 3, or negative pi over 2. I think it kind of makes it easier. I just figure out which denominator it is, and it's the negative. So again, that's for arc sine and arc tangent. Arc cosine, however, with the negatives, what quadrants do I look in? 0 to pi. Is that any weirder? No. The good news with arc cosine of a negative, of course, -1 would be over here. Well, what's his name? Pi. You don't have to worry about arc cosine of the negatives aren't as bad. If I had arc cosine of -1/2, I think, okay, that's this guy, and you name him normal. That's 2 pi over 3. Done. So arc cosines aren't too bad. It's the arc sine and arc tangents that usually people miss because they forget that to name them negatively. Now lastly, what about arc sine of 3? What's that? Give me the arc that has a sine of 3. Well, you go none of them because sines have to be between -1. People, that's how this domain comes into play. Do you notice with sine and cosine, the domain is -1 to 1, meaning what you have to put in for this value has to be between -1 to 1. If it's not, you do not get an answer. There's nothing. So being that 3 is not between -1 and 1, this doesn't give me an answer. So that's what you'll be practicing this evening, doing those arc trig functions. It's just like the unit circle with one little addendum in quadrant 4 and where you're looking. But hopefully you can do those. All right, peace out.